Unit 7 is dealing with limiting reagents. Now on page 196 in your textbook, you are given an introduction that says a recipe analogy. Right, so what they talk about there is exactly what we had before with our hot dogs, that it is a recipe how to make hot dogs. We need Viennas and we need buns. We have 5 Viennas, we have 4 buns, so therefore how many hot dogs can we produce? We can only produce 4. So which one of these two is limiting the reaction? Obviously my buns. So I can only make 4 because there's only 4 buns. This is one thing known as my limiting reagent, and this one is my excess reagent. Right. So per definition, my limiting reactant is the reactant that is used up first during a reaction, and it determines the amount of product formed. That is the most important part of this sentence. That determines the amount of product formed. The excess reactant, that is the reactant of which some of it remains at the end of the reaction. Right, so there's going to be products plus some of this unreacted reactant still left in my reaction. Right, let's do the example that we have. We're going to read through it. Copper turnings react with dilute nitric acid, produce copper nitrate, nitrogen oxide, and water, according to the following balanced chemical reaction. Right, it's already balanced, but you're also going to check that it is balanced. You can see this one's balancing is a little bit hard, but not impossible to do. 520 grams of copper and 650 grams of nitric acid reacts in a closed container. Now this is the way that you go and identify I'm dealing with limiting reagents, because 2 of them are given, 2 masses are given, right? One of them is going to be used up before the other one, and it's not always the one that is most that is used up. You cannot just go and assume that. Right, so what are we going to do? If we look at the next page, it gives us the question that says, determine which of the reactants is the limiting reactant. So I'm going to use my little page there so that we can keep our information with us. Copper turnings reacts with dilute nitric acid. Yes, which one is the limiting reactant? Now we're still going to use our same concept of stoichiometric calculations. But this time I'm going to see, by making use of the number of moles, the mole ratio, which one is going to be used up first. Right, so what is step 1? We need a balanced equation, which we do have. We're not going to redo that. Step 2, convert what is given to number of moles. So that and that needs to be converted to number of moles. So let's do the copper on the one side and the nitric acid on the other side. Number of moles is mass over molar mass, which is 520,7 divided by, and we need the molar mass of copper, and the molar mass of copper is 63,5. Right. This one, number of moles, is mass over molar mass. Our mass was 650 over, and now for the molar mass of the nitric acid, it is 63. So you go and calculate those values. Right. So this works out then to be 8,2 moles. And this one works out to be 10,32 mole. Right, that is what I have, and the ratio in which they are working is 3 moles of copper reacts with 8 moles of HNO3. Right, so now we're going to go into a test phase. I'm calling it how I test which one is going to limit my reaction. Right, so I'm going to have my copper, number of moles of copper, in relation to my number of moles of HNO3. So my ratio is 3 to 8. Now if I have 8,2 of this one, right, how much of this will I need? Now if I do this, this one is my got, and this one is my want. So to work out this number of moles, I'm going to say the number of moles that I want is 8,2 multiply want over got. And 8,2 8.2 times 8 equals divided by 3 is, and I get an answer of 21,86 mole. Right. Now, is this possible? If all of this was used up, I need 21,86 moles of that. I don't have that. I only have 10,32. So is this reaction possible? Is it possible for all the copper to be used up? No, it's not. Right. So what is my conclusion? So therefore, what is limiting the reaction? What will be used up first? My HNO3. The moment that I'm going to use it until I get to 10,32, and then the reaction cannot take place anymore, but there will still be copper left. So what is my limiting reactant? My HNO3 is limiting the reaction. Right. I can also go and test it with the other one. So I'm again going to say number of moles of copper to number of moles of nitric acid. It's 3 to 8. And this I must say, let's say all of this is used up. How much of this do I need? So what is this now? My got, and this one is my want. So to calculate the number of moles of copper that I need in order to react with 10,32, I'm going to use 10,32 multiply want over got. Right, so 10.32 multiply 3 divide by 8 equals, and I see 3,87 grams. Sorry, not grams, mole. Right, so what do I see? I've got 8,2. I only need 3,87. Then all of the HNO3 will be finished. So is this possible? Yes. So therefore, what is my limiting reactant? The same as before, HNO3 is my limiting reactant. Right, so we figured out what was my limiting reactant. Okay, so now we go on with the question. The question now continues and say, the mass of the excess reactant that does not react. So the one that does not react. Right. So what is in excess? From this reaction that we have here, which one is in excess? This will be in excess, and this one is the limiting reactant. So I need to go and find out, or I don't even need to go and find out because I've already calculated. If I have 10,32 of this one reacting, how much of this one will be reacting? It is the 3,87, and the rest will be in excess. So dealing with that then, the number of moles of copper in excess is the number of moles of copper minus the number of moles of copper used. So what number of moles of copper did I had? We've calculated it as 8,2 minus how much was used? 3,87. And 8,2 minus 3,87. 8.2 minus 3.87 gives me 4,33 mole in excess. But it was not mole that was asked, it was mass that was asked. So to calculate my mass, I'm going to use my number of moles times my molar mass, and for what? For copper. So 4,33 multiply 63,5 times 63.5. So I have a mass of 274,955, so 96 grams of copper in excess. Right, so that is the mass of copper that's going to be unreacted. There is more. Calculate the mass of H2O produced. Now, what is going to determine how much of this is produced? The copper or the nitric acid? It's obviously the nitric acid that's going to determine how much is forming of this one. And from my nitric acid, I know that the number of moles of HNO3 that reacted or that reacted is 10,32. And my number of moles of nitric acid to the number of moles of water according to the balanced equation is 8 to 4. I don't have 8, I've got 10,32, and this one I don't know. Right, so now to find this, the number of moles of H2O is therefore 10,32 multiply 1 over got, 1 over got, 4 over 8. 10.32 times 4 divided by 8 equals, and I get 5,16 mole. But that is now the number of moles of water that will be produced. The question was what mass of water is produced. So the mass of water produced is number of moles times molar mass of water, and that gives me 5,16 times, and H2O is then 2 plus 16, which is 18, and 5,16 times 18 is 92,88 grams of H2O will be produced. Right. And finally, the volume of NO2 at STP. STP, standard temperature pressure, so my molar volume 22,4 cubic decimeters. Number of mole is volume over molar volume. That's where we're heading towards. I want to know what is the number of moles. I'm looking at the ratio between the nitric acid. Why? Because that was the limiting reactant. The number of moles of NO. Ratio according to my balanced equation, 8 to 2. 8 to 2. I have 10,32 of this. I don't know how much of that will form. I use my number of moles of NO is going to be 10,32 multiply 1 over got 2 over 8. 10.32 times 2 divided by 8 equals, and I get 2,58 mole. So I have 2,58 is equal to the volume over the molar volume. So times that by 22.4 equals, and I get a volume of 57,79 cubic decimeters. Right, so that brings us to activity 1 on page 197 that you can go and complete. Our next section is examples of gaseous reactions. We have airbags in cars, combustion of fuel, thermal decomposition of ammonia. All of this is interesting reads. You are welcome to go and read through the whole chemistry of it and how the reactions work. On page 201, there's some revision. We've already given you the first set of revision. Please go and do the rest as well. The answers will be given to you again in our Google Drive that will be created. Right, grade 11s, I hope that you are following all of your notes on quantitative calculations, and if you have any problems, that you will contact your science teachers. Thank you. Good luck.